Okay, we learned how to calculate type 1 and type 2 error probabilities. So I brought another numerical example. In this example, we will think about like COVID vaccine again, about its waning immunity. So suppose that we believe that the immunity decreases to 50% after, like within 6 months after getting a COVID vaccine. So we'd like to test it. So how many people remain immune, like have antibodies after COVID vaccine in 6 months? So what we are going to do is we are going to randomly choose a person who had COVID vaccine 6 months ago, and we will define a binary random variable x, which takes 1 if the person still has antibodies and 0 otherwise. And we are interested in the parameter p, which is the probability of success, which means the probability that a person maintains antibodies 6 months after the COVID vaccine, right? That is a probability, but we know that the probability of success equals its mean for a binary distribution. So we are going to apply our method for the mean, okay? So we believe that our hypothesis is that this probability is 50%. So 50% of people have antibodies 6 months after the first COVID vaccine. And remember, when we have a binary structure, like the overall process is the same, but we need to use the standard deviation according to the binary distribution. So in a binary distribution, the standard deviation is this. And remember, this is based on the null hypothesis in hypothesis testing. We are testing hypothesis of 0.5, then it implies the standard deviation of 0.5. We are going to use like throughout this exercise, as long as we assume the null hypothesis is true. Okay, so then in this case, suppose that in our data we surveyed 100 people, and we found that only 42 of them had antibodies 6 months after the vaccination. Then, and if we use 10% significance level, what are the critical values? So it's your exercise for you. So 10% significance level, 10% implies z alpha over 2 equals 1.64, right? So if you know this, then all the other numbers are automatic, kind of automatic. So mu0 is the mean we assume in the null hypothesis, which is 0.5. S is the standard deviation implied by the binary distribution, which is also 0.5, right? And square root of sample size is 10. So in this case, do you reject the null hypothesis or not? Remember, we observe 42 people having immunity after the vaccination. Do you reject? Okay, so here the idea is we believe that the probability is 50%, but we allow certain margin because of the random error in the sample average. We are willing to accept our null hypothesis if the sample average is between 41.8% up to 58.2%, right? These are the critical values between which we are going to accept the null hypothesis, right? So in this case, we got 42% from the data. So data tells you 42%, which is greater than the lower critical value. So it's 42% is between the critical values. So it's like close enough to your null hypothesis. So we cannot reject the null hypothesis. The answer is no, right? So our sample average is 42%, which is between the critical values. So the null hypothesis is not rejected. Now, what we are going to think about, okay, this is, so far, if you do not reject the null hypothesis, that just completes hypothesis testing. It is just one-shot hypothesis testing result, but we need to now think about the probability of potential error after making this decision. So based on our data, we made our decision, but it can be an error. So we will think about that now. So if it was an error, what kind of error is it? Can it be type 1 or type 2, or can it be both or none? What kind of error is that? So to analyze that, what we have it like so first remember, type 1 error is when you reject or correct null hypothesis, and type 2 error is when you do not reject a wrong null hypothesis. So in this case, you did not reject the null hypothesis, so this cannot be a type 1 error, right? So type 1 error happens only when you reject. So your decision cannot be type 1 error, but it may be a type 2 error. Like for example, like as I said here, suppose that the true probability is 42%. So your data is actually very correct. There is no random error at all. But just unfortunately, the truth is within the margin, within the critical values. So you just thought there was a random error, so you could not reject the null hypothesis. That's exactly type 2 error. The truth is not your hypothesis. Truth was not 50%, but you could not reject. So that's if it was an error, if this was an error, that is type 2 error. Okay? So now we will think about this type 2 error. Okay. In this case then, from now on, we will assume that the true probability is 42%. True probability is actually 42%, and we observe 42%, right? And then what is a type 2 error? When the truth was 42%, but our hypothesis is 50%, then how much we can make a type 2 error? That's what we are going to do. So we are calculating probability of type 2 error, which is the probability of not rejecting the null hypothesis. Okay, not rejecting the null hypothesis means the sample average is between the critical values. That's when you don't reject. Okay, so if the sample average is between these two numbers, that is type 2 error. But in this case, we will assume that we are assuming that the probability is actually 42%. Probability is 42%, but the sample average happened to be between the critical values, so you cannot reject. That is our what we are going to calculate. Okay. How do we do that? Now another tricky thing here is, now because we changed our assumption about the true probability, now we calculate based on 42%. So your standard deviation must follow that again, right? Previously, we used 0.5 as the probability because that is part of the null hypothesis, and we assumed the null hypothesis was correct. But now we are assuming that the null hypothesis is wrong, but actually there is another truth. The actual truth is 42%. So your standard deviation must follow the new truth. And approximately, it is 0.49. So we are going to use 0.49 as the new standard deviation. Of course, we are going to use this new standard deviation to standardize the distribution of sample average, right? Sample average is normally distributed, so its parameters depend on the new truth, like 42% for the mean and 0.49 for the standard deviation. So the mean is now assumed to be 0.42 here, and standard deviation is 0.49. So we are using these for our standardization. Then you get like some numbers like this, and then put it into the calculator, Excel. Then you will get 51.548%. So more than 51%, you could make a type 2 error. Like, I mean, if the truth was 42%, then more than half, more than 50%, you will not be able to detect it, right? So this is how what we need to understand when you do hypothesis testing and like assess its accuracy, right? Okay, this was a short video about this numerical example. So in the next video, this is the end of this was the end of the first half of this chapter. In the second chapter, we are going to change our topic and we will talk about a hypothesis testing for null hypothesis with inequality. Okay, so I will come back with another new example. See you there. Bye.